All right, lads, listen up. Today we're talking about electrical testing, and trust me, this isn't as dull as watching paint dry. We're talking about your safety here, and when it comes to electricity, safety is paramount. Think of it like driving a high-powered sports car. You wouldn't hit the gas without checking the brakes, would you? Electrical testing is all about making sure your electrical installations are safe and sound. We're talking about checking for faults, making sure things are wired correctly, and ensuring that if something does go wrong, your safety devices will kick in and protect you from a nasty shock, or worse. Now, before we even think about poking around with a multimeter or a Mager, we need to talk about safety gear. Always, and I mean always, wear appropriate personal protective equipment, PPE, when dealing with electricity. This includes insulated gloves, safety glasses, and flame-resistant clothing. Remember, electricity is a powerful force and should be treated with respect. Never work on live circuits unless absolutely necessary, and always double-check your work. Right, now that we've got the safety briefing out of the way, let's get down to business. First up, we're going to tackle continuity testing. This is the most basic electrical test, and it's all about making sure that electricity can flow freely through a circuit. Imagine you're a spark trying to get from one end of a wire to the other. Continuity testing is like checking the road for potholes and roadblocks. To perform a continuity test, you'll need a multimeter set to the continuity mode. This mode usually emits a beep if there's a continuous path for the electricity to flow. Simply touch one probe of the multimeter to one end of the circuit and the other probe to the other end. If you hear a beep, you're good to go. If not, you've got yourself a break in the circuit somewhere. Next up, we've got bonding conductors continuity testing. This is basically the same as continuity testing, but instead of checking a single wire, you're checking the connection between two conductive parts. This is important because it ensures that if one part becomes live, the other part will also become live, which should trip the circuit breaker and protect you from harm. Now, let's move on to insulation resistance testing. Insulation, as you might have guessed, is the protective layer that prevents electricity from flowing where it shouldn't. Over time, insulation can deteriorate, leading to dangerous leakages of current. That's where our trusty Mager tester comes in. A Mager is a specialized piece of kit that measures high resistance. To perform an insulation resistance test, you'll need to disconnect the circuit from the power supply. Connect one lead of the Mager to the conductor and the other lead to the ground. The Mager will then apply a high voltage between the 2 points and measure the resistance. A high resistance reading means your insulation is doing its job. A low reading, well, you've got some investigating to do. Polarity testing is another important safety check. This test ensures that the live and neutral wires are connected correctly. A simple way to think about it is that electricity wants to flow in a specific direction. You wouldn't drive your car in reverse all the time, would you? Polarity testing ensures that the electricity is flowing the right way. Section 4. Earth fault loop impedance and earth electrode resistance testing. Now, let's talk about earth fault loop impedance testing. Imagine a scenario where a live wire comes loose and touches the metal casing of an appliance. Bad news, right? That's where the earth wire comes in. It provides a low resistance path for the electricity to flow to the ground, preventing you from getting a nasty shock. Earth fault loop impedance testing ensures that this path is clear and effective. To perform this test, you'll need an earth fault loop impedance tester. This clever device simulates a fault current and measures how much resistance the earth wire provides. A low reading means the earth wire is doing its job and will protect you in the event of a fault. Next, we have earth electrode resistance testing. The earth electrode is the metal rod driven into the ground that provides the grounding point for your electrical system. Over time, the connection between the electrode and the soil can deteriorate, reducing its effectiveness. Earth electrode resistance testing measures the resistance between the electrode and the ground, ensuring that it's low enough to provide adequate protection.